All right, Unit 2, as this whole year is, we are still looking at these polynomials. So now we have all our factoring tools. You've learned them all. You have lots to remember from 8th grade. The greatest common factor, the difference of two perfect squares. And now we added on this year the difference of two perfect cubes. And yes, you've got to be able to, boom, say that formula. And then boom, the sum of two perfect cubes. Basically, it's the same formula. All we do is have some signs changed. But today we're going to concentrate on this trinomial factoring. Trinomial factoring generally involves, actually it always involves, quadratics. So we're going to zero in on quadratics today. That means a degree of 2. And the last one we always had was factor by grouping. We're going to see more factor by grouping, but not today. So if you go back to 8th grade, and there are 3 other painful memories, when we have a quadratic, something raised to the second power, we had 3 ways to find its zeros, its roots, its x-intercepts. I'm going to keep saying that over and over again so that you understand all 3 words are interchangeable, because Common Core will use all 3. We had good old-fashioned trinomial factoring, or, as I like to call it, bridges and tunnels. A binomial times a binomial. And then we did our bridge and our tunnel. If something can factor now in Algebra 2, it's a godsend. But it's not going to. Then we have our friend the quadratic formula. Remember? Opposite of b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Not sure if you did that in geometry or not, but it's back to haunt you. And then the last, completing the square. So we're going to take some time to review those right now. Now, your homework tonight is obviously going to contain quadratic formula and completing the square. If you cannot complete the square, then you need to go step by step, come back to this video, watch it. Come to this part, pause, do the homework problem, pause, do step 2 of the homework problem, pause, do it over. Compare and contrast, compare and contrast. So, example 1 here says find the roots of the following. This function, 2x squared plus 5x minus 3. Well, as soon as I say find the roots, find the zeros, what you're doing is you are taking this equation and you are setting it equal to 0. You can set an equation equal to any number. You can find out where this parabola crosses the line y equals 4. Then you'd set it equal to 4. But right now I want to set it equal to 0. So this does factor. 2x, x. I need numbers that multiply together to 3. Well, it's going to be 3 and 1. But remember, I have to build my bridge and my tunnel. My bridge here is 6x. My tunnel here is x. Can a 6x and an x ever get me a positive 5? Yes, when this x carries the negative sign. So that is going to be the negative, and then this is going to be positive. -1, positive 3 does indeed get me -3. And don't forget that it's set equal to 0. You may remember that you have to try, if you would put the 3 here and the 1 there, it wouldn't have worked. So, this tells me it crosses the x-axis at 1/2 and -3. So I made up one that had a leading coefficient so you can remember it, especially for completing the square. And now, since we're going to do the same problem all 3 different ways, we're going to get the same answers. So the quadratic formula. I'm going to take a second here to clearly write out that A is 2, B is 5, and C is -3. And that's because the general form of a parabola is ax squared plus bx plus c. Yeah, it's all coming back to you, slowly but surely. So the quadratic formula is generally the one kids like the most. because it's easy. Just plug and play. Negative b plus or minus square root of b squared minus 4 times a times c all over 2a. So it's negative 5 plus or minus, careful here, a negative times a negative really turns this into a positive. So I get 49 over 4, negative 5 plus 7 over 4, negative 5 minus 7 over 4. So right, this is 2 over 4, which is a half. Negative 12 divided by 4 is negative 3. I'm getting the same answers as over here. Remember, plus or minus means I'm going to have 2. All right, completing the square. This is where we're going to have to take our time. But remember, make sure the leading coefficient is 1. In this case, my leading coefficient is 2. So we are not having a leading coefficient of 1. So I divide out, meaning I am going to divide everybody by 2. Divide out and set equation equal to 0. Okay, x squared plus 5 halves x minus 3 halves equals 0. Please don't turn them into dirty decimals. You can handle fractions. You're big boys and girls now. Move the constant over to the right side. Ah, remember doing this? I want to isolate the x's. Now, step 3 is where the completing the square magic happens. We want to be able to write this parabola in vertex form, completing the square form. All right, so this little chart here is just a way to remind you. The b value is 5 halves. Take half the b value. Well, half of 5 halves is 5 fourths. Hopefully you hear Mr. Alan Wick in the back of your head. Double the denominator. It's my best Alan Wick impression, sorry. Now, square that half. 25 over 16. We're going to add this new value to both sides. Here is the completing the square magic. I'm going to add that 25 over 16 to the left. And since I did something to the left of the equation, I have to do the same to the right of the equation. Now this is where I'm saying when you are doing completing the square, if necessary in tonight's homework, you should be watching along with this video. Speed to this part, pause, compare and contrast the problem you have at home to this. Follow me step by step. Rewrite the left side as a perfect square. Remember, that's in vertex form. And that would be x plus 5 fourths squared. Remember, we always just did our cheating method here, and the value for half b is what got put in here. If I squared this, I'm going to get this side right here. Square the first, x squared, square the last, 25 over 16, double the middles, 5 halves. Equals, well, let's see, I add this together, and that becomes 49 over 16. Hey, it's starting to look like this. I got a 49 over here, I got a 49 over here. Now, if I solve for x, I'm going to do this in one step. This is where you should know completing the square becomes very quick when you become adept at it. I've got to get this x alone, which means I have to undo addition here, subtraction, squaring. So when I look at this, it's x equals, that 5 fourths is going to move over as negative 5 fourths, plus or minus the square root of 49 over 16. See, because I'm going to take the square root first. And then if you see, negative 5 fourths plus or minus 7 over 4, which is basically what I had over here. So my roots are the same. All right, example 2, one more. Anytime you read zeros, roots, or solve, you are essentially doing the same thing. You're getting an x value when the function is at 0. I'm trying to find those roots again. I'm going to drill that into you. So in example 2, it says solve the following. And when I look, it's set equal to 0. So we're factoring. We can use the quadratic formula or we can complete the square. Well, one thing I think you should do is I think you should head on over to Desmos. And I think you should type it into Desmos because it's going to give you the answers. There are my 4 answers. Makes sense. X squared means I have a degree of 4. So therefore I should have 4 possible answers. And if I look carefully, 2 answers are pretty. 2, 0. We like 2, 0. 2.33, which is a fraction 2 1/3. So that means somebody can be factored. But these are irrational, and Desmos rounds them to the nearest thousandth. So now I can go back here, and I can see that one side is going to factor. And with Desmos, it told me that my answer for my roots were x equals 2, x equals 2 1/3. So if I go backwards, that comes from x minus 2. 2 1/3, well, that's 6 7/3. And that really comes from 3x minus 7. So that was the factor of this left. Now I got to factor this factor. And that's the one we're going to do by completing the square. I'm going to come over here, x squared minus 4x plus 1 equals 0. Move the constant over. Take your b value, take half of it, and square it. Add that number to both sides. Rewrite as a perfect square. Now we know that we just use that half value. And this is where it becomes very easy. I know I'm going to end up undoing by square rooting. So I have plus or minus radical 3. And then this 2 is going to move over negative. It's going to move over as positive. So there are my other roots. So my other roots over here are x equals 2 plus radical 3, x equals 2 minus radical 3. So there's my degree of 4. There are my 1, 2, 3, 4 answers with all my work to support my answers. Now the other cool thing about Desmos is I can come right here and I can type in 2 plus the square root of 3. Look, it tells me it's 3.732. 3.732. And then here I can type in 2 minus the square root of 3. And that answer is 0.2679 approximately, 0.26. Hey, did my work correctly. Got the same thing Desmos got. All right, so tomorrow in class, we are going to do this one together. So if you want to pause while the video is going to end, write this down so that you have it in your notes tomorrow for us to go over. Bye.